Welcome everyone to today's webcast. And as always, I thank you for taking time out of your very busy day to spend some time with us to learn about creating knowledge workers for the greener product marketplace. We could not be more proud of the faculty who have come onto this webcast series to share the work, the innovative work and creative work that they're doing in each of their schools in various parts of the world. We have educators from all over teaching using sustainable minds, and today one of the faculty that we'll be revisiting is from Australia, and you'll see some of the curriculum going on at RMIT. But today, it's all about jobs and the economy, developing curriculum to attract students to schools today means integrating environmental sustainability into all types of curriculum. And schools that do so will attract the students who care and will respond to the market demand from manufacturers and other employers who are looking to recruit students who have been trained in life cycle thinking and environmental sustainability practices. So this is the economic cycle, if you will, of education. Schools want to attract the best students, and manufacturers want to hire and recruit the best students. And that's how we will make change in the marketplace. We're also very proud to talk about the adoption we've seen since we launched Sustainable Minds software in 2010, again, all around the world, both in industry and in education. And we are in the process of updating this map. This is just a little bit out of date. And we have more dots to add, and we like to call them in our more obscure countries. This is our favorite dot to date. This is a student from the University of Mauritius. And we're really, really honored to get the attention, again, of people all around the world. Typically, our webcasts feature educators who have been teaching using Sustainable Minds in the previous semester or two to inviting them to present. And typically, each webcast has featured educators representing different disciplines. And we thought for this series, it would be helpful for educators who are looking to develop curriculum for the upcoming semesters to aggregate customer stories by discipline and share those so that folks in each discipline can learn more in one sitting and learn from the array of educators that we've featured in the past. Typically, we really like to invite educators that represent themselves a range of getting started, from educators who've had no experience teaching things related to environmental performance, but are expert in engineering, business, or design in some facet of those. Because we want to be able to show the ease of integrating this type of curriculum into any level course by any educator with any degree of knowledge, previous knowledge about how to do it. Today, we just so happen to be featuring educators who, for the most part, have quite a large amount of experience and knowledge around environmental sustainability and life cycle thinking and LCA. And one educator who has extensive experience in the industry as a practicing designer and head of product design at a major global corporation. And I thought it would be fun to start with this presentation by Layla teaching life cycle thinking in industrial design education in Australia, and which is a second-year course for industrial designers, and then moved to two of the educators teaching at the Minneapolis College of Art and Design, known as MCAD, where there are three educators in three different courses using Sustainable Minds, building on this kind of base course and taking it into more specifics relative to the particular discipline. I've reserved one of those educators' webcasts for a subsequent webcast. And so we'll look at Kurt and Jeremy's customer stories, where again, this is an introduction to systems thinking, and this is an advanced collaborative product design course. And then followed by, we'll wrap it up with Richard Braunstein's customer story. Again, in undergraduate curriculum, but at the senior level, and also inclusive of graduate students who are focused on industrial design degrees. So again, a range of educators teaching in different types of ID programs, both on premise as well as distance learning, which MCAD, you'll learn more about when I talk through the story, is a distance learning school. Before we gear up to dive into the actual customer stories, I wanted to just do a quick introduction of Sustainable Minds and our mission to those of you who are new to Sustainable Minds. And thank you for those of you who are here with us today for the first time. That's really appreciated. So our mission as a company is to operationalize environmental performance into mainstream product development and manufacturing for the purpose of driving revenue and growth through greener product innovation. We combine two disciplines into one software solution: Ecodesign, which is the practice of life cycle thinking, and lifecycle assessment, which is the globally recognized scientific method for measuring the relative environmental impacts of products and systems. You can't teach people just to think differently and design differently and hope to come up with truly higher performing, greener solutions. You have to measure. And what we see repeatedly in customer stories and case studies that folks give is the refrain, well, I thought we'd make this change and it would demonstrate a really meaningful improvement, and then we went to model it and it actually had no impact or made things worse. So you can't just think differently without measuring. You have to do both. And conversely, you can't just measure without thinking differently in the design process, because you'll probably only get incremental improvements because you're not doing anything differently. Thinking differently means ultimately arriving at new innovative ideas, and then measuring, which is not innovative in and of itself, but measuring in early stage product development is innovative. The two of those things combined get you truly greener results. And you're going to see that repeated in every single customer story that I'm going to share with you. Now, I use the term greener and the term environmental performance interchangeably because green doesn't really have a meaning. But people talking about developing products are all about performance. The traditional criteria like functional performance, now environmental performance just sits alongside the other product development criteria, including cost, ergonomics, aesthetics, safety, where product teams and manufacturers already have tools and metrics to be able to evaluate concepts or scenarios or products and be able to make trade-off decisions, but until recently have not had a way to model the environmental performance, to have credible data to also include in that design and trade-off decision process. And ultimately, there are real business drivers. I don't think there's anyone who can dispute that anymore or not care about those drivers, like cost of resources, regulation, supply chain risk. And really, ultimately, the upside is building a greener brand, coming up with innovative new products, and new revenues from products and customers you wouldn't otherwise have had. So we have always believed that designing greener products is an innovation driver that should actually lower costs and increase revenues. And companies who make it a goal will achieve a competitive advantage. But all that to say, it requires new knowledge, new processes, and new tools. Now, we are very focused, and the Sustainable Mind software was purpose-built for use in early stage product development. And here's the reason why. 75% of the manufacturing costs are committed by the end of the concept stage. Once you get into detailed design, it's very expensive to make changes. Once you know what you're making, it's hard to make changes. But it turns out that those decisions, like material selection, energy requirements, recyclability, that define the actual product, lock in the environmental performance of the product. And so if you can't measure and look at alternatives in early stage product development, then you got to live with it or incur expense and time making changes later. So we named the company Sustainable Minds, which many people think is an unusual name for a software company. But the whole point is people have to think differently in the same way before you can get them to act differently. And the starting point is to shift the concept of what is the product's life cycle beyond just cradle to gate to the full life cycle of the product, from raw material acquisition, material manufacture, product manufacture. You've got transportation and distribution between each of those life cycle stages. You've got the use stage, and ultimately different scenarios at the end of life. Now you're ready to start thinking from a life cycle perspective and start applying eco-design strategies to each of those life cycle stages. So these are high-level strategies that can be considered in design to look at how to improve performance or reduce impacts in any of these life cycle stages to come up with better results. There's a stage prior to even material selection, which is the innovation stage. Rethink how to provide the benefits. Just because something has always existed in a certain form doesn't necessarily mean that form needs to persist to provide the same functional performance or needs. Big way to innovate, rethinking how to provide the benefit, and ultimately strategies around the product life cycle that inform design and drive new ideas. Now, life cycle impact assessment or life cycle assessment, again, is an internationally recognized and standardized process for measuring the impacts of a system or a product. And this is the standard process. Like any other research study or project, you set the goal and scope. This is what I'm going to learn. This is what I'm going to get done. And this is what I'm going to include in the study. Then you go out and get all the pieces to include, call it the inventory analysis. And then you build a model from all those inputs, and ultimately get the results. What are the impacts from all the inputs into the model? And have I answered the questions that I've set myself up to get answered? And so it's a iterative process, which design is an iterative process. So you're always interpreting and considering results along the way, informing new and different decisions, new strategies to apply, and you're done with design when you've answered your goal questions. Or you've run out of time, or you've run out of budget, but such is not the case in education. Because we were bringing, for the first time, a tool, a lifecycle assessment tool for non-LCA users to use in product development, we tried to merge some of the language from product manufacturing with language from lifecycle assessment. And so we came up with this term, the system bill of materials, because it's the bill of materials from the entire product system, not just the materials. So it's all the inputs from material processing, energy use, consumables, transportation, end-of-life impacts. And so the way lifecycle assessment works, and this is probably the geekiest slide you'll see in this presentation, is that every one of these inputs can be described by its chemical composition. And when you put those chemicals through the lens of an assessment methodology, each of those chemicals can be attributed to one or more categories of environmental impact, and each of those categories then can contribute to one or more types of damage, either to human health or to the built or natural environment. That's how life cycle assessment works. Now, the way that we've made that technical process understandable to non-LCA experts or non-chemical engineers is we've created a single figure score methodology. So taking the underlying life cycle inventory data, that chemical composition data, taking the impact results of an input like a material to each of these 10 impact categories, characterizing, normalizing, weighting each of those results to roll them up into a single figure score. So what we provide as a result in Sustainable Minds is an impact factor that is a single figure score of all these impacts, plus we pull out the global warming impact score and convert that to carbon equivalence. So now you have two scores for each input, an overall impact and a carbon equivalent impact. And the underlying data that we use is from EcoInvent or the US LCI database or other publicly available sources. There is an extensive ISO 14040 methodology report, which you can download from the Learning Center, the first page of the methodology section, which is quite extensively explained online for those of you who really want to dig into the science. And when there's not data available to model what you need to model, and this is either for education or in industry, this is a service that we provide to create new impact factors, either from publicly available sources, or if it's not available and you need it, we can create a proxy based on similar kinds of inputs, or we can actually work with manufacturer suppliers or primary data to make impact factors to model just what you need. The whole idea is to teach, though, that there is no such thing as a green product. Green is a relative value. Something can only be greener than something else. So it's all about comparisons. So Sustainable Minds software is designed to be just that, is a concept comparison generator, that when you build your very first model, we refer to that as the reference, it automatically becomes the reference. You can copy the reference or build an entirely new model, and every time you do that, it automatically is added to this comparisons, this concepts tab, that gives you not only the millipoint score, that impact factor score, but it gives you the carbon equivalent score, and most importantly, it gives you the performance improvement or impact increase. These are the numbers that are most understandable to regular people because you can understand percent performance improvement or increase in impacts. And we also clearly track the quality of the assessment. I'll show you how we do that. You yourself have to tag the project or the input. Yes, I'm estimating this input, or no, it's from literature, or no, it's from measurement, which is the most explicit input. And we encourage, when you're in a design process, to name your concepts using one or more of the strategies that you're exploring to remind yourself of which concept ultimately is providing you either better results or getting closer to answering the questions that you've set up in the goal and scope. So you're able to model and get real-time LCA-based results. You don't have to wait. Every time you add something to the model, you can go check out the results. So in summary, Sustainable Minds Eco-Concept and LCA software consists of software, data, the ability to collaborate, the ability to learn and share knowledge. And again, importantly, it's not just LCA software. The ability to rapidly create and compare concepts is unique functionality, which is why we make the effort to refer to it as our eco-concept and LCA software, designed explicitly to benchmark and compare, to provide quantified estimates of environmental performance for non-experts. It's a standardized system, and ultimately, it's easy to interpret and share results. The Learning Center, which is part of every subscription, is the equivalent of about a 150-page textbook on eco-design and LCA. You can see there's considerable content, case studies, examples, tables, and every student has their own access to it because it's part of the subscription. Same with the educator. You could build a whole course just from the content in the Learning Center, or use modules from it for particular parts of your course. With that demo, if you will, let's get into some of our customer stories. And I'd like to start out with Layla, who is a very innovative industrial designer and practitioner in Australia. She's here in the US now, working on a number of very interesting projects. And she shared this customer story with us a few years ago, where she was teaching at RMIT University in industrial design. She had founded and runs a sustainability design agency called Eco Innovators. She is a very compelling speaker and presenter, and has had many guest opportunities to present at events like TED, on Australian TV, has won a number of awards, and really, to use maybe a little bit of a tired expression, but really does think outside the box. So the format of each of these customer stories is consistent. When we invite an educator, we actually give them a template and say, here's how we'd like you to tell your story. We're going to talk about the school, talk about the department you're teaching in, the course you're teaching, your own background, what's the project, show examples of the project, and then do a wrap-up of the key learnings that the students had, your key learnings as an educator, and the importance of teaching this kind of thing in industry and the trends that they're seeing in industry. So I'm going to tell that story for each of these educators. So RMIT is in Melbourne, Australia. The Industrial Design Department is part of the School of Architecture and Design. It's one of Australia's largest technical universities. The ID program is equivalent to most general ID programs here in North America, and a very strong focus on not only traditional design skills, but now sustainable design. She was teaching a core studio design course. It was the first semester for second-year students. standard 13-week studio that was revised in the year she was teaching to include a large eco-design service and sustainability core component. Students do have access to sustainability courses, but this is a core subject now. So in this industrial design program in 2011, sustainability became a core component of the curriculum. And students are required to learn LCA, eco-design thinking, product service systems, and eco-design strategies. So this really was a perfect tool to support the intent and the initiatives of that program. So I'm going to show you a few examples that she shared of her students' projects. The first one is from her student, Dustin Bailey, who designed this storage system. And what she shared was really the approach that she was teaching to help students. She taught a mind mapping technique, and to help students kind of evaluate where in this mind map there might be some entry points into where a new product or a product service system could be identified. And so this is some of his thinking about that. Here's a life cycle map we actually have in Sustainable Minds, some content to instruct on how to actually make a life cycle map. He started looking at where some of this could be reused or revised. He started making a list of materials. This is all part of identifying what you're going to include in your assessment scope, your system boundaries, what's going to be excluded. And then from some of the concepts that he developed from that mind mapping exercise and where there would be some opportunities, he started just looking at where some improvements could be made by having benchmarked an existing refrigerator using whatever inputs he used, but then copying that refrigerator model and doing an investigation of eco-design strategies to see where meaningful performance improvements could be gained. These are some of the results that come directly out of Sustainable Minds. This shows you the overall scorecard, the impacts by impact category. You're going to see that this view of impacts by life cycle stage and impacts by system bill of material input are more directly informed by the scenario planning. So here's the existing refrigerator, shows the greatest impact was in the manufacturing, in end of life. And here in this modular concept, the impacts switched to the greatest impacts being in the use phase and significantly reduced in manufacturing. The point to all this is to show that Sustainable Minds can be used in a very, very high-level conceptual way just to kind of inform very early on, should I explore this or should I explore that? Which is going to give me some better direction as I get more explicit in my investigation. You'll see in some of the other examples that I share, the students are going to get very explicit in their exploration and in their modeling, but Sustainable Minds is designed to be very general so that it can be used to solve answer very high level questions, as well as more explicit ones. And so these, again, are some of the visualizations that Layla encouraged her students to create, to tell their story about how they're thinking about breaking down the problem they're solving, looking at raw material acquisition, impacts in the life cycle stages that they were looking at, and looking at the inputs into the life cycle stages that they were exploring to come up with ultimately a solution. And then having some results to be able to substantiate their insights and their considerations, and moving forward to support design decisions to move forward. a very nice way of demonstrating the eco-design strategies that the student explored and how those strategies drove changes in the model and in the results, and then got more specific about how this general strategy was being investigated for, in this case, his modular refrigerator product. Another one of Layla's students worked on a microfinance kit, where this microfinance kit provided instructions for how this particular NGO could help women doing startups in developing worlds develop products that not only would be sustaining from an economic perspective, but also sustainable from an environmental perspective, so that even in what we might consider to be very simple businesses making very simple products, consideration of natural resources is significant and certainly paramount when there's not an unlimited supply. Let's put it that way. Here's an example of a product, a hand grinder that this student developed using this model and set of principles and eco-design strategies, and a very nice way of visualizing. For those of you who attended the business strategy webcast, and those of you who may be considering attending the manufacturing and engineering webcast next week, which you're welcome to do, the thing that is unique to design is that students are not only taught to think differently, but to be able to visualize their results and tell visual stories. And you'll see that that's an important part of each of the stories that the educators are telling, is how to combine these visualization and concept development skills to also visually tell the story of the environmental performance investigation and the decision-making process. So the key learnings from the students were to understand how life cycle thinking and life cycle assessment go together, to understand the environmental impact of materials and processes, and to integrate eco-design strategies into the design process. The key learnings for educators were how to assist students in transferring this kind of knowledge to students, the ability to give students a hands-on way to direct them in their own self-study and in their own learning, and certainly making it easier for non-LCA educators to facilitate learning in LCA areas. The trends that Layla identified that are evolving in education to prepare students for industry is the adoption of sustainable minds in other Australian universities, and that students are starting to find their own way to sustainable minds, even if it's not being officially used in the course. We do have a lot of students from Australia using the software, signing up for trial accounts. Certainly cross-disciplinary, and ultimately, the goal is in education today to rapidly upskill folks from not just having traditional skills, but coming out with differentiated skills. And this learning also applies to training and education in industry, that manufacturers and consulting firms are always looking for ways to upskill and enhance the services and the knowledge that their employees can bring to the table. Another key learning, and we hear this all the time. Educators will ask other educators, wow, was it hard to teach students to use sustainable minds? And the answer is nope, not at all. In fact, most of the educators don't include any kind of tutorial in the course because students can just get on, start using it. We have a lot of help content integrated into the interface, and they can get going and get pretty capable very, very quickly. And ultimately, just going to jump to the end. The key is that thinking differently and using LCA and teaching that early in the educational curriculum reinforces the idea that sustainability isn't something that gets added on later. It doesn't wait to be taught till the senior year. It's taught first semester, second year students probably have come out of a foundation program, and it becomes core to who they are and how they're taught to work. So that brings me to our next set of educators from Minneapolis College of Art and Design. This is a master's degree program in sustainable design. And we're going to look at two of the educators and two of the courses that Sustainable Minds is being used in today. Quick overview of MCAD, which is how folks refer to it, is it's a fully online program spanning all different kinds of department, continuing ed, undergraduate, graduate. It's exclusively for working professionals, taught by other working professionals, and in this discipline, taught by practicing sustainability professionals. And the students are from all over, as are the faculty, and they're taught to work collaboratively along with other types of skills you'd expect in a master's degree program for working professionals: leadership, design strategy, problem-solving skills that then can be applied to the problems that are being worked on in industry, either by themselves or by others. So the students who are part of this program are, again, working professionals from all different types of disciplines. It is the only master's degree program of its kind in the world, as it's fully online, focused on sustainability, and it is integrated in a US-based art and design school. It's a boutique program with a limited enrollment and getting profound results. So let me start by sharing with you Kurt McNamara's story. He teaches an introductory course called Systems Thinking. Kurt himself is a practicing design engineer. He teaches a range of courses, and he specializes in biomimicry, which is a fascinating discipline looking at how to understand what happens in nature and being able to apply what happens in the natural environment to what we do in the manufactured environment. And he works to connect those skills with lifecycle thinking. So this is first year students. He teaches a systems approach. So Ecodesign strategies are a systems approach to a product lifecycle. It's required, and it's only for a week. And I really want to emphasize that it's a module in a one semester course, and the goal is to get their feet wet, see how easy it is to get LCA data, and then the challenges of LCA. So he does a very, very simple project where he asks each student to select a very simple product that doesn't have a lot of different components. And so now what you're seeing are the presentations from the different students and how they're visualizing their story, their learning. So here's the students' selection of trial-sized dental floss. What Kurt is teaching is a very traditional approach to doing a tear down of an existing product. So you find the product, tear it down, identify all of the components, and now you're ready to go and model that product. Now here, this starts to integrate the way that they're telling this story visually about each of the items that they identified. What did they call it? What was it made of? What were the impacts? Ultimately, the total impacts. There's another story. A lot of times when a teardown project is taught, students will go to Goodwill or a secondhand store, buy an old appliance, and tear it down. So this was a study of an iron. This is a Bic lighter, and a lot of content packed into this presentation, but very interesting presentation of the components and what that student learned. Remember, this is a 1-week project. This is taking some of the results from Sustainable Minds, and all of this content that you're seeing in here is in the Sustainable Minds project. This text is annotated, that text is annotated, but these are parts of the screenshots from the Sustainable Minds project. And finally, this is a project looking at a toothbrush and identifying the learnings that the student had very quickly by just changing the polypropylene to PLA. They get a performance improvement. So bottom line, key learnings, the students were able to say, hey, largest impact can be anywhere in the product system. You got to measure. And the key learning for the educator, easy to use, to teach LCA, will have a lot of utility in the marketplace, easy to teach systems design. Teaching a challenging topic like functional unit can be challenging, and being able to visualize it and show what happens when you change the functional unit is a powerful learning. And again, same thing with the system boundary, what to include in the study and what not to include in the study, and to be very explicit about that. So with that 1-week introduction to LCA and Ecodesign, Jeremy, who is a practicing industrial designer, teaches actually also at Stanford as an adjunct faculty, and is in the doctoral program at UC Berkeley in their mechanical engineering program. Teaches an advanced collaborative product design course. So Jeremy is a very well-regarded sustainable design strategist. He speaks, he's created a lot of content on sustainable design, and like I mentioned, he teaches at a number of places. And this collaborative product design course was designed to teach tools and strategies working in virtual teams on real products for real companies. And so this is, the criteria was for professional master's level students. So the students in this course are industrial designers or engineers working on real products for real companies. So they're bringing a lot of background to the table. Now Jeremy is teaching them about integrating environmental performance into that product design process. So here's the project. Here's one of the student projects. He had them select a fairly sophisticated product and do a pretty thorough design brief of that product. So what's the problem? What are the use cases and functions? A preliminary assessment of impacts by benchmarking the existing product, and what are the redesign goals for the next generation of this product. The design brief, he teaches them to include priorities for redesign that also include priorities for environmental performance improvement or impact reduction, because they've done the benchmark, the baseline, as part of kicking off the project. And then, this is really, I think, pretty powerful. based on that baseline assessment, looking at the impacts, writing a complete design brief, not just environmental performance, but environmental performance being part of the design brief that looks at all the other criteria. The team generated 9 different design options, really that are quite far-reaching. Everything from a partnership with Nintendo that included a gaming component to it, to all the way down here, door hinges for kinetic energy to power the product. And so then they did go on and model each of those options to understand the viability of those options and whether or not each of those options would meet those performance improvement goals or not. And so there's some information about how each of those bared up under that kind of scrutiny. And then here's the option that was selected as the final. The door hinges for kinetic energy was the winning option. And here's the business case and the conclusion of the brief explaining why this option was selected, why customers will love it, what are the financial benefits, and how it reduces the environmental impact. Key learnings: great green redesign concepts can inform lifetime energy use. LCA can decide which component wins, particularly when all else is equal. And again, whole system thinking causes more radical redesigns. For educators, it allows them to build eco-impact literacy. It gives designers more technical analytical skills, and it informs a better design process with wider creativity and qualitative rigor. In terms of trends, reinforcing using LCA as a front-end tool, looking at the ability to compare strategies, like collaborative consumption, end-of-life impacts, and how to present the information. Also, that now that students can perform simple LCAs, how to use the LCAs to determine life cycle impacts and guide decisions. These skills all translate out in the marketplace. They can help inform buying decisions, and how those get integrated into product marketing. And the bottom line is, right, how to take products that actually are greener, that are higher performing, and be able to tell those stories in the marketplace based on the eco-design strategies that were used. The last educator whose story I'll share with you is Richard Braunstein, who teaches at Georgia Institute of Technology in the Industrial Design program. And his course teaches integrating streamlined LCAs into the product design process. So he is an adjunct faculty at Georgia Tech. He is the director of product development at YKK, which is a global building products manufacturer. He started teaching sustainable design quite a while ago, but certainly is still evolving, and really does teach holistic principles. And I'm going to show you what he does. Here at Georgia Tech, the program has an undergraduate and graduate degree curriculum to prepare people to go out into practice. They teach cross-disciplinary courses. They teach collaborative work, and periodically participate in real-life design projects through sponsored studios. This course is third year and graduate students to prepare students for addressing environmental performance in product development as part of the core design process. And so what he showed in this kind of tour of his course is how he has exposed the students to understanding the product definition phase, how to use different ideation tools, how to look at different parameters, different attributes to make trade-offs, what tools they might use for that, how all of this is iterative and cyclical to drive solutions that you continue to iterate on, and finally you choose the one to go implement. And nothing here we haven't already said. Here he's talking about the environmental burdens associated with each of the life cycle stages, which is kind of the definition for those eco-design strategies. These are the burdens. What are the strategies you're going to want to pursue? And he uses a variety of texts and reference materials to broaden the student's knowledge. He is very intent on expanding the design toolbox that designers use in making decisions about products. And uses those tools and those methods to drive ideation, and now marrying it with the visualization of those concepts. And that is critical to industrial design skills and curriculum, is to teach kind of rapid visualization and storytelling. And so here is a great set of sketches to explore the sustainable design process for a variety of handheld tools, particularly in this case, this drill, and breaking the strategies down into the visuals, or to visualize each of the strategies that they're employing in each product. Here's a toaster example, another toaster example, more toaster examples. Here's a more finished example of looking at a clock, another toaster example. And ultimately, the key learnings are consistent with the others: to prepare design students to integrate environmental considerations, foster team learning and encourage self-learning, helping educators teach design for the environment or environmental performance, giving them a hands-on tool, teaching them to measure, to dispel greenwashing. And ultimately, the takeaways, again, are quite consistent. Teaching hands-on skills using today's tools, create value for the students to bring into the marketplace. And that supports our refrain, which is all about jobs in the economy. Schools who have this integrated into curriculum will create students that manufacturers want to hire. Sustainable Minds is designed, again, for use in education or industry. And we have pricing for both purposes. Anyone can take out a 7-day free trial. You just go to our website. Individual industry pricing for individual subscriptions starts at $1,400 and decreases as you buy more. We have very, very aggressive educational pricing. It's the same product. There's no limitations on it. $350 a year for educators and $49 for half a year for 6 months for students. And we have even more comprehensive and aggressive quantity discount programs for schools who are using it in classes, departments, and across the school. You can go to our website and listen to the webcast replays for all of the educators whose stories I shared with you today. You can hear them tell their stories themselves, as well as all the others. And I'd like to thank you for coming to our webcast today and spending time with us to learn about Sustainable Minds, EcoConcept, and LCA software. And I want to thank those of you who have stayed till the end. It looks like all the questions that have been posed have been answered. And so I'm going to give you back 3 minutes of your day that you didn't know you would have and wrap this webinar up right now by saying have a great day and hope to see you at our next webcast. Bye-bye.